Welcome to qnawire.
For part A, we can find the electric flux. This would be equaling the electric field, which is constant over the surface, cosine of phi, which is also constant over the surface, multiplied by the integral of the area. And so this would be equaling E cosine of phi times A, and this would be equaling 14 newtons per coulomb, multiplied by cosine of 60 degrees, multiplied by the area 0.250 meters squared. And we find that the electric flux is going to be equaling 1.8 Newton meters squared per coulomb. For part B, we know that the electric flux is independent of the sheet. As long as the magnitude of the electric field and the angle are constant at all points. And then finally, for part C, part 1, we have that the electric flux is equaling the magnitude of the electric field times A times cosine of phi. We can then say that the electric flux is, of course, largest when phi equals 0 degrees, where essentially cosine of phi would be equaling 1. And so here the electric flux would be equaling the magnitude of the electric field times the total area. And for part 2, we can get the electric flux is smallest at phi equaling 90 degrees. And this is where cosine of 90 degrees is equaling 0. So here, the electric flux would equal 0. This would be your answer for part 2 and your answer for part 1. The end of the solution. Thank you for watching.